Hi everyone, welcome to Data Structures and Algorithms 101 with your professor, Claire Zhu. Today we're going to learn how to encode and decode your very own messages using Huffman coding. So, this was created by David A. Huffman in 1951, super cool guy on the right, and it's a method to encode messages based off of frequency. So, it's going to use a data structure known as a binary tree, which essentially has one parent node and two children nodes. And it's going to associate each character with a sequence of zeros and ones. More frequent characters, such as the vowel A, is going to have a shorter sequence. So essentially, this is going to maximize the amount of data that you need to encode your message. More frequent characters are going to require less data in order to save them. Now let's try it out for ourselves. That's going to require a frequency table with all of our characters, as well as our message of zeros and ones. Our algorithm is essentially going to convert our zeros and ones into our characters. So the first step is that we are going to have to order our frequency from least to greatest, which is already done. And then essentially the main gist of this algorithm is it is going to constantly take out the smallest two numbers and then create a larger, bigger node with them. So in this first case, it's going to start off with the T and the O, which combine to create 12. And then our I and our S, which combine to create 13. This is where it gets a little bit tricky. So you would think that you would combine the 10 and the 15. However, we have a smaller node, which is going to be our 12 node. Don't forget about our 12 and our 13. So next we combine our W and our 12 node, which combines into a 22 node, and onward from there. So this is going to be our final tree, and as you can see, all of our letters should be at the bottom. They are going to have no children. So now, the zeros and the ones are going to associate with the left side and the right side. Let's write out all of the encoded messages of our letters. As you can see, the letters that are more frequent have shorter encoded parts. So the M and the N are going to be the shortest. And now let's encode our message. If you followed along with the video, you should get the final message of Women in STEM. Thank you guys for watching, and I hope you learned a new method of encoding and decoding messages.